Hey everyone. So now in lesson 5, we're going to take a little bit of a shift in direction here. The last, say, 2 lessons, we've been really focused on multiplying and this notion of expand and simplify. Expanding meant we were going to get rid of the brackets through multiplication, and then simplifying means we were combining like terms that we could. Okay, and all of that is multiplying a polynomial. Today we begin, and really this is the beginning of the second half of this unit, because for the rest of this unit, we're going to focus on something called factoring. And factoring is essentially going in the opposite direction. But I want to take a couple of minutes and kind of build that concept with you, okay? So, first of all, as a quick little review, I gave you a question like this in yesterday's homework, and I thought I'd just give you one more just to practice. I want you to find the area of the shaded region. And I would love it if you humored me, pause me, you do it yourself, and then come back and look at what I did. So what I've done is I said, okay, the area of this shaded region, which is this blue section here that you can see my mouse on, well, I need the area of the whole thing. The area of the whole thing would be x plus 1 times 2x minus 2. Then I need to subtract the white rectangle. Okay, so the area of the white rectangle would be where I'm getting this x minus 2, or sorry, x multiplied by x minus 2, and then I'm subtracting that because I'm taking that away from the whole area. What's left over will be the area of the shaded region. So I have to take my x here. Let me get my pen on here. X times 2x and x times negative 2, and then my 1 times 2x and my 1 times negative 2. That's essentially what's going to happen when I break this up into the distribution law. Okay, so I've distributed, I've broken it up first so I can do the distribution. So x times 2x and x times negative 2, that's what I had just said. I already did the distribution on this last term. So now I need to distribute the x here and distribute the 1 here, and then combine like terms. And my final answer is x squared plus 2x minus 2. Okay, now expand the following. Well, this is old hat for you now. You guys are awesome at this. 3 times 2x is 6x. 3 times 5 is 15, so I end up with 6x plus 15. On the other end here, 5 times 2a would be 10a, and 5 times negative 6c would be negative 30c, okay? So that shouldn't feel new or different or anything like that. We've been doing that for the last couple of days now. Okay, expanding refers to forming a product. That's what we just did, okay? You are getting rid of the brackets by doing the multiplication. Now, the important thing you always need to realize in math is everything that we do in math is bidirectional. What that means is if I can go from here to here, I can also go from here back to here, okay? If I can go in one direction, we can also go in the other. Going in the other direction in math is often called performing an inverse operation. So you've dealt with this already when you've done solving algebra equations, right? If you were trying to get rid of an addition of 4, you would subtract 4 from both sides, because subtraction is the inverse operation of addition. So subtraction will undo what the addition was doing, okay? It'll go in the other direction. The inverse of expanding is factoring. In this process, you are given the simplified version and you're asked to work backwards to create a multiplication sentence from it, okay? So in expanding, you are trying to get rid of brackets. And I really want to make that point super clear to you, because I know I said this in another lesson earlier, but it's important that you know what the question's asking you to do, okay? If I ask you to expand something, in your answer, you should not have brackets, because the whole purpose of the expansion was to get rid of the brackets. If I ask you to factor, though, I'm asking you to create a multiplication sentence, which is actually introducing brackets, okay? If I asked you to factor the number 15, you may write 15 as 5 times 3. So I took my simplified version and I created a multiplication sentence. So I actually introduced brackets there, okay? It applies to the concept of a greatest common factor. it applies, sorry, the concept of a greatest common factor to algebraic expressions. So there's just a little chart here to compare between multiplication and factoring. If you were to multiply factors to form a product, you'd go 3 times 7 equals 21. If you were to multiply or expand an expression, you'd go and use the distributive law. So you'd go 3 times 7x is 21x, and then 3 times -2 is -6. If you are to factor, let's go here first. If you're to factor a number, that's just what I did on the board. You took 21 and you wrote it as a product of 2 factors. If you were to factor over here, what you're actually doing, and we're going to unpack this a bit more as we go, but you take out the greatest common factor. So when I look at 21 and 6, I know that both of those have a factor of 3 there. And so I take the greatest common factor to the front, and that's what starts my multiplication sentence. I know it has to be 3 times something, and then the something ends up being 7x minus 2 when I divide out the 3 from 21x, and when I divide out the 3 from -6, okay? If I was to take this 3 and now multiply it, I'd be right back to where I was. It would give me the exact same thing, okay? All right, so using algebra tiles, factor 4m plus 12. Well, what does that look like with algebra tiles? Let's start there. Here is what 4m plus 12 might look like. If I'm thinking about this in the concept of algebra tiles, I want to think about groupings. So what sort of groupings could I make? Well, I could do this. I see 2 groups where each group contains 2m plus 6. Okay? Everybody see that? Now, I could try something else. I could say, okay, what if I saw this? I could separate this into 4 groups where each group contained x plus 3. Okay, so I just factor that in 2 different ways. I have 2 groups of 2m plus 6, so that's where the 2 times 2m plus 6 came from. Or the one I'm showing you now was 4 groups of m plus 3, so I have 4 times m plus 3. So now it begs the question, which one's better? Okay. When you are asked to factor, you are usually asked to completely factor. You'll often see that word completely, okay? And what that means is you want to do as much as possible. So in this case, 4 is the better answer because you're wanting to take out the greatest common factor. If I looked at this guy for a sec, this 2, that is factoring, but then when I look at this 2m plus 6, there's still a greatest common factor inside there. So I didn't take out as much as possible. When you are factoring, your goal is to always take out as much as you possibly can, okay? And so that's why you'll often see the questions worded as completely factor. Okay, so find the greatest common factor of 24x squared y to the 5 and 32x cubed y cubed. So what we want to do here is just kind of take it piece by piece. So if I looked at 24 and 32, you need to tell me the greatest common factor of 24 and 32. And that would end up being 8. Okay, so I got an 8. Now, I've got x squared and I've got x cubed. So think of that as I've got x and x in this pile, and I've got x, x, x in this pile. Okay, well, what's common to both of those piles? There are 2 x's that are common to both. Okay, so x squared would become part of my greatest common factor. Okay, and then likewise, if I want to look at the y, I have 5 y's here and I have 3 y's here. So what's common to both? Well, y cubed would be common to both. Okay, so my greatest common factor there would be 8x squared y cubed. Now, that's just stating what the greatest common factor is. This is not factoring yet, because what I want you to remember is factoring involves creating a multiplication sentence. There is no multiplication sentence here. This is just a monomial. When I go to factor it, what happens is I say, okay, this is my greatest common factor. Now I'm going to tell you what's left when that guy comes out of 24x squared y5 and when that guy comes out of 32x cubed y cubed. I put that in here and then I've got this multiplication sentence. That's where we're going, okay? So when I go to completely factor, I will end up with, like, if I have a term plus a term, doesn't matter how many terms are there, it could be 7. What will end up happening is I'll take the greatest common factor out, and then I'll be left with each of those terms again after I've divided the greatest common factor out, okay? So we're gonna practice a bunch of these together. 4m plus 12, well, what's common? M is not common to both, so I can't take the m out. But between a 4 and a 12, 4 is the greatest common factor there. So I take out the 4, and that would leave me with m plus 3, okay? You can always check your work. If you go 4 times m, you get 4m, and if you go 4 times 3, you get 12. Now, I just want to give you a little warning on that. Notice that this is where I stopped the question. The question asked me to factor. I have created the multiplication sentence, and that is the end of the question. If I go to check my work, that's great, but don't do it down here and make it look like you're answering 4m plus 12, right? Because then if your final answer now says 4m plus 12 because you checked your work, I don't know if you actually knew where to stop or not. So if you're gonna check your work, make sure that you box this as your final answer so I know that that is your final answer, okay? All right, let's head over to 4c squared plus 6c. Well, between a 4 and a 6, the greatest common factor would be 2. And between a c squared and a c, the greatest common factor would be c. So 2c is my greatest common factor. I take that out, and that would leave me with 2c plus 3 inside the brackets. 7a squared b minus 28ab plus 14ab squared. Well, I know I can take a 7 out. 7 is common to all of those. I have 2 a's, 1a, 1a. So there's 1a common to everything, and there's 1b common to everything as well. So 7ab is going to be my greatest common factor. When I take 7ab out, I put it to the front and I open up a bracket because that's the beginning of my multiplication sentence. The first term, 7a squared b divided by the 7ab that I'm taking out would leave me with a. Negative 28ab would leave me with negative 4, because a divided by a is just 1 and b divided by b is just 1. And then my 14ab squared would leave me with 2b. Okay? Okay, let's try these three. 6n plus 9, I'm looking at a 6 and a 9. N is not common, but between the 6 and the 9, I could take out a 3. So I take out the 3 and I'm left with n plus, 2n, sorry, plus 3. Okay, 6n divided by 3 is 2n, and 9 divided by 3 is 3. This guy, when I look at the greatest common factor, the greatest common factor is going to be 2c. Very, very common mistake that kids make in this guy is they end up telling me that my answer will be 2c, and then they say it'll be c minus 5c3, and they stop there. Now, the problem with that is they ignored this term. They partly ignored this term because they're thinking in their head, well, that's my greatest common factor. But you have to remember what you're actually doing is you're dividing that greatest common factor out. What's 3 divided by 3? What's 10 divided by 10? The answer that you should have told me there was 1. So what's 2c divided by 2c? It's a 1. Don't forget that 1, okay? The number of terms inside the brackets will always be the same as the number of terms you start with, okay? So we end up with 2c bracket c minus 5c to the 4 plus 1, okay? Okay, and then this guy, 27, 18, 36. I can take a 9 out of all of that. I can take out 1r. There's 1r common from all three. And for s's, there's 2 s's common to all three. So I can take out an s squared. So 9rs squared. And that would leave me with 3r when I divide this guy by my 9rs squared, right? 27 divided by 9 is 3. R squared divided by r is r. And s squared divided by s squared would just give me a 1, which is why it's not there. Minus 2r squared, that's the result of going negative 18r cubed s squared and dividing it by the greatest common factor. So negative 18 divided by 9 is negative 2. R cubed divided by r is r squared. And then my s squares are gone because they divide out. And then negative 36 divided by the 9 is negative 4. My r's divide each other out, and I've got s cubed divided by s squared. That will leave me with 1s there, okay? All right, common factoring can also involve a whole polynomial as the common factor, not just a term, okay? Some students find this easier as the common factor is often in brackets. So what I want you to see here, let me just type for a sec. Let's say this said 3xy plus 5y, like that, okay? You would look at that and you'd say, hey, y is common. So if y is common, I'm gonna take y out and I'd be left with 3x plus 5. Well, there's no difference here. Your commonality is x minus 4. X minus 4 is common to both terms. And so I can say, hey, I can pull the x minus 4 out and stick it in the front. Well, what will be left is 3x plus 5. Okay, so that would look like this. I pulled out the x minus 4, and what's left was the 3x plus 5. So it ends up being x minus 4 times 3x plus 5. Okay, so we're going to put a couple things together now. Take a look at the examples below. What you need to see in both examples is that there are 4 terms and there's no GCF. So what we're going to try and do with this is look at something called factoring by grouping. So first question, 2x squared minus 3x plus 2xy minus 3y. I don't have a greatest common factor, but I do have 4 terms. As soon as I see that I have 4 terms, there's this concept that I want to try where I just look at the front 2 and I just look at the back 2. Okay, so if I just looked at the front 2, I'm looking at 2x squared minus 3x. Is there something that I can take out of there? And the answer is yes, there is. I could take out an x. One x is common to both of those. On the other side, on the back half of the equation, if you want, I'm looking at 2xy minus 3y. What's common to both of those is y. I could take out a y. Okay, so watch what happens when I do that. So I've just color-coded these so I could show you that I'm looking at the front 2 and the back 2. I take out the x from the front 2. I take out the y from the back 2, and now my heart goes pitter-patter. I get super excited because I see here 2x minus 3 and 2x minus 3. I now have a common factor between these 2 terms of 2x minus 3. So I can pull that common factor out just like I did in that last example. I can pull that common factor out to the front, and then I'd be left with x plus y. So that looks like this. My final answer would end up being 2x minus 3 times x plus y. Okay, so we're going to try it here. Now, this one, if you pause me and try it, you're going to get frustrated. And the reason you're going to get frustrated is because you're going to say, hey, I totally got what you did, Hill. I'm going to factor the front 2, I'm going to factor the back 2, and then you're going to get stuck and it's not going to work. And the reason it's not going to work is because you're not quite in the right order. I would always write these in the proper order first, which would be in descending powers. So let's put the 6 down to the back so that we're in the right order. Now, pause me and try it. Underline that front 2, underline the back 2, see if you can factor out the front 2, factor out the back 2, and see if that gives you a common factor to pull. So in the front 2, I took out an x squared, and that left me with x plus 2. In the back 2, I could take out a 3, and that left me with x plus 2. So now I see this x plus 2 is common to both, okay? So if the x plus 2 is common to both, essentially, I can factor it out, pull it to the front, okay? And then that would leave me with the x squared plus 3. So my final answer for that would be x squared plus 3 times x plus 2. All right, so let's try a couple together. Here we go. I see that my x minus 2 is common. I'm going to pull it to the front. I'll end up with x minus 2 times x plus 3. This is still factoring. I want you to remember what factoring is. Factoring is creating a multiplication sentence. So this was not a full multiplication sentence, right? Because it was this dude plus this dude. I've now made the same thing except it's in the form of a multiplication sentence. Now it's this dude times this dude. That's what the whole purpose of factoring is to create that multiplication sentence. Okay, so k squared bracket n plus 3 minus bracket n plus 3. Now, I actually see the same thing in the brackets. My question to you here is, what's in the front? What's right there? I didn't know I could make an arrow like that. That was fun, sorry. Right there is a 1, okay? So this is like a minus 1. When I pull out the n plus 3 then, I will end up with n plus 3 times k squared minus 1, okay? All right, this guy, what's common? Well, the y squared plus 5 is common. So if I pull that to the front, I'll have y squared plus 5. And then what am I left with? Well, this is an interesting conversation. I'm left with y squared plus 5. So I end up with y squared plus 5 times y squared plus 5. That's a binomial times itself. Anytime I take a number and times itself, we call that squaring the number. So it's the same thing with the binomial. I'm not going to leave it like this. I'm going to now write it as y squared plus 5 squared, because that is considered more simple. There's no point in being redundant and saying the same things over and over again if I can group them together with an exponent. Okay? Okay, so now this guy looks a little messier, but what I want you to see again is p minus 1, p minus 1, p minus 1. P minus 1 is common to everybody, so I'm going to factor him to the front. If I factor him to the front, I'm left with 6m plus 15n minus 3. Okay, so p minus 1 got pulled to the front, and it's going to be multiplied by 6m plus 15n minus 3. Now, I did one more step here, and the reason I did one more step is because I'm looking at this. Remember, the question will always say completely factor. So when I see 6m and 15n and negative 3, I say, hey, there's a 3 common to all of those, so I'm going to pull the 3 to the front. That's where this guy came from. And then what's left is 2m plus 5n minus 1. That's this guy with the 3 divided out of each term. Okay? Good. All right, so here I am again. I got 4 terms and I don't have a greatest common factor. So I'm gonna think to myself, can I factor the front 2, factor the back 2? Go to the front 2, I could take go to 3x, and that would leave me with x minus 7. Or to the back 2, I could take go to 4, and that would leave me with x minus 7. I now see that the x minus 7 is common to both, so I'm gonna pull the x minus 7 to the front, and I'd be left with 3x plus 4. So x minus 7 times 3x plus 4. Okay, 15AD plus 20A minus 18BD minus 24B. I have 4 terms there. There is no greatest common factor. So again, I'm going to try factoring the front 2, factoring the back 2. In the front 2, I can take out a 5A. In the back 2, which is this note that I just threw at the bottom here, I want you to notice that the back 2 starts with a negative sign. If your front number, and in this case, the negative 18 is the front of the back 2, right? If your front number is negative, you always pull the negative out, okay? It makes your life way easier. So I pulled out a negative 6b, not just a b, because my front term there was negative. Okay, so I pulled out the 5a and I was left with 3d plus 4. I pulled out the negative 6b and I was left with 3d plus 4. I now see that the 3d plus 4 is common to both terms. So I pull that common factor out and I'd be left with 5a minus 6b. So my answer here is 3d plus 4 times 5a minus 6b. Okay. Awesome. I hope this felt okay. Do lots of practice. You've got some practice there, and you know where to find me if you have any questions. Okay? Have a great day. Take care, guys.